generally occurs when you have a parabola where the vertex is on the x-axis. So that would typically be the base graph. That's what's going to end up giving you volcano. The second one typically comes when you have a linear function, and the two pieces will be in whatever quadrants the line goes through. The third one you haven't seen before. It's another variation of volcano. It still starts with a vertical asymptote. Again, doesn't have to be on the y-axis. But instead of a horizontal axis or a horizontal asymptote, what ends up happening is it has a slanted asymptote. And we call this an oblique asymptote. An oblique line just means one that's on a slant. And so you end up getting part of the volcano on one side and part of the volcano on the second. Okay, so very similar to the second graph, it's just following a slanted asymptote as opposed to a horizontal asymptote. Okay, so we talked volcano last year. We talked the first variation. This one is new. First time you've seen with an oblique asymptote. Kind of coming back a little bit, maybe. Okay, then we looked at two vertical asymptote graphs. So typically one's on the left and one's on the right. They're typically symmetric, but they don't have to be. And we end up getting volcano on the left, volcano on the right, and in the middle, anyone remember? Parabola. And they can be reversed. The parabola could be on the top and the two volcanoes could be on the bottom. Sorry, there is, yes, on the x-axis. Thank you. Any of you remember the name, my favorite graph in the whole world? Sad clown face. Rob, you got a good memory. Is this all the only thing you remember from Unit 8? Again, mathematicians, we look at this visually and we say, well, those are the eyes, that's the sad face, the asymptotes are the tears. Very sad, sad clown. Variation on sad clown face that we didn't talk about last year, so this guy is new as well. Starts the same, two vertical asymptotes. Usually symmetric, but they don't have to be. Horizontal asymptote. Oh, sorry, let's just go back to the first one. This comes when you have a parabola that's under the x-axis, or the vertex is under the x-axis. So it's just a parabola that's not on, but pushed down a little bit.
Where did the third volcano come from?
I'm not telling you yet, because it's new. You haven't seen it yet. Nor am I going to tell you the second sad clown face, because it's new too. Sad clown face, you get volcano on the bottom, on the left. The other volcano piece ends up on the top on the right, so they're opposite. And then you get this really cool swoopy in the middle. So if we go left to right, it's down, up, down, up. And it can all be reversed. It can start up, down, up, down. Where have we kind of seen this idea before? What did we do this the beginning of the class with our dance moves? Which one kind of? Tan kind of has this feeling there. Okay, so it's just a variation of sad clown face. You just haven't seen it before. We did a no vertical asymptote graph last year. So just a horizontal asymptote. And these guys typically look like this. Approaches the asymptote, goes up into a little bump, and comes back down towards the asymptote. Rob, do you remember? Speed bump. Again, not creative people. We looked at it. We're like, yep, looks like a speed bump. Had Manitobans picked it, I think we would have called it mountain, because that's a pretty big bump for us, but for the rest of the world, probably not. This comes from a parabola that's above the x-axis, so it doesn't have any x-intercepts, which means it doesn't have any vertical asymptotes. Graph with holes is new. It can be a line, it can be a volcano, it can be a sad clown face, it can be a speed bump, it can be anything. The trick with this is it has a hole right in the middle of the graph. So if we do a linear graph with hole, it continues to the left, it continues to the right, but there's an empty space right in the middle. No vertical asymptotes, no horizontal asymptotes, no asymptotes, just a hole right in the middle. Oh, you'll find out. What do you think we call it? Oh, we're a little more creative than that. Graph with hole. Like I thought we could have at least done golf course or something. No, graph with hole. Pretty straightforward people, us mathematicians, graph with hole. So I'm just going to flip back. This we saw last year, this we saw last year, this one we're going to talk about again this year, or for the first time this year. This is from last year, this is new. So we're just building upon what we did last year, we're just adding on a different kind. This we saw last year, we're adding on this one. So I'm going to go all the way back to the beginning, and we're going to start with how do you find vertical asymptotes. So just in case you remember nothing from Unit 8, you factor everything is step number 1. If you factor and you can cancel something, that's going to be a hole. We didn't do these questions last year, so you never would have been in this situation. If it doesn't cancel, that's a vertical asymptote. Okay, so I'm going to show you with an example, but you factor anything. If you have a binomial on the bottom that can cancel, that's a hole. If it doesn't cancel, it's a vertical asymptote. So grab some paper, because we're not going to have any space on there. And all we're just going to practice right for the first one is just finding vertical asymptotes. Then we're going to go on to horizontal and oblique. Then we're going to go on to other stuff. Then we'll eventually get to the graphing maybe tomorrow, depending how your brains feel. So I just want to go really, really slow with this because I know it's fuzzy for a lot of you from last year. Now for visual peeps, this is something somebody showed me last year, I'd never seen this before, is I'm going to highlight the first 5 letters. Because to me, a radical and a rational are very, very different, but I know to you guys sometimes they sound like the exact same thing. So radicals are square roots. The way you can remember rationals is the first 5 letters form what word? Ratio. And what is a ratio mathematically? It's a fraction. It's a number out of a number. So this will help you remember fractions as opposed to square root kind of graphs. So eventually our goal is to graph these. In order to graph them, the first step is finding the vertical asymptotes or holes. So we're just going to practice the first step all by itself, and then we'll eventually get to the graphing. So first step, you factor anything you can, the top, the bottom, whatever is factorable. Can we factor the top? How do we know? Because it's just x plus 3, so there's no squared involved, we can't touch it. Can we factor the bottom? How do we know? Because it's a perfect square because of the x squared. Confirm x plus 3, x minus 3. What can we cancel? The minute you can cancel it, it tells you graphically that's going to be a hole. You're not going to have an asymptote there. You're going to have just a little empty space on the graph. Where does it occur? Well, we solve that binomial. So if we take x plus 3 and equate it to 0, so just like we solve regular NPVs, x is going to equal -3. That tells you on the graph, wherever x is -3, there's going to be that hole. If it doesn't cancel, that tells you it's a vertical asymptote. Where is it? Well, we set it equal to 0, just like we do with NPVs and solve. So we say x cannot equal 3. Remember, for asymptotes, we write cannot equal. We don't care about holes. But asymptotes, we write cannot equal because it doesn't exist. That's how to find holes or vertical asymptotes. You factor. If it cancels, it means there's a hole in the graph. If it doesn't cancel, it's a vertical asymptote. Do I care what was on the top? Not at all. The top is useless to me in determining vertical asymptotes and holes. Okay, y equals 2x plus 2, x minus 4. Can I factor? Where? Okay, what can I take out of it? Okay. Can I factor the bottom? Nope. Some visual people, they like to put the brackets around the bottom because it helps them seeing the canceling. If you need to do that, great. If you don't, that's fine too. Can I cancel? What does that tell us about the bottom? It's a vertical asymptote. And where is it located? What about the x plus 1 on the top? Doesn't matter, could care less right now. It's going to help us determine something else later, but in terms of holes or vertical asymptotes, I could care less what's on the top. If it cancels, great. If it doesn't, great. Don't care, don't even look at it. Show me your thumb so far. I'm getting this, I'm kind of getting this. Okay, try C and D with somebody, or by yourselves, antisocial people. I'm feeling like you're at least done C, since you're already kind of talking D. C, can we factor the top? Give it to me. Confirm. Okay, can we factor the bottom? Can we cancel? Nope, that tells us this is a vertical asymptote. X not equal to -1. Can we factor the top for D? Okay. Confirm. Can we factor the bottom?
Yes.
Yes.
You can factor out a negative.
We could factor out a negative. Okay, so if we factor out a negative, divide them each by negative.
X minus 4.
Agree? Can we then cancel? Now, if you wanted to skip that step, that'd be fine. You know when we're canceling like that, it's going to become -1. So to answer your question, no, it's still canceling, right? Whether it gave you -1 or a +1. What does that tell you about this x-intercept? Okay, it's a hole. Now just be careful with the solving for it. How do we solve for either a hole or a vertical asymptote? Set the entire bottom equal to 0. So I'm going to include that negative. This case, it wouldn't matter. X is equal to 4. Okay, so this is why when we cancel ones that are backwards, we get a negative. It's because that's what you're actually doing is factoring out a negative. Questions so far? Okay, let's go on to horizontal and oblique. Oops, sorry, let's go back. Okay, so how do we get rid of this negative in front? You can multiply or divide. So if we multiply 0 by -1, it's 0. And then we just add 4. Okay, horizontal are kind of new. Oblique is definitely new. So last year I was like, yeah, I'm not supposed to talk about horizontal, but it seems so funny to me to graph without talking about it. So I was just like, yeah, draw it, but don't worry about it. Now we're going to worry about it, and I'm going to tell you the math behind it, where it comes from. So just a reminder over here that a rational function is an equation, or a polynomial divided by a polynomial. So some kind of expression divided by some kind of expression. Step number one, if you have to do what's called analyze the degree of the numerator and denominator. So way back in grade 9, we taught you the vocabulary word degree. What's the degree of a polynomial?
The highest exponent
Yes, it is the highest exponent.
for on a variable.
Does somebody else hear a weird noise? What is that? I know, it sounds like a helicopter. Oh, snowblower. Hopefully it is not a snowblower. I've not seen outside since 7 o'clock, but hopefully not. So a linear equation, for example, we say has a degree of 1. A quadratic equation has a degree of 2. A cubic, which we learned last unit, has a degree of 3. So that's what it means by determine the degree. What about a sine function, for example? Well, it's not a polynomial, so it's never going to creep into these kinds of questions because it has to be a polynomial divided by a polynomial. So we're only worried about lines, cubics, that kind of thing. There's going to be 3 possibilities. The degree of p of x is 1 more than the degree of q of x. That means the polynomial on the top is 1 degree higher than the polynomial on the bottom. Second possibility is the degrees are equal. Third possibility is the degree of p of x is 1 less than the degree of q of x. Those are the only 3 possibilities you're going to see in this course. So first thing we do is we decide the degrees, and then we decide which of these situations do we have. Is p 1 more than q? Are they equal, or is p 1 less than q? The notation I use to remember is I say degree plus 1 over degree for the first situation. If that doesn't mean anything to you, then don't write it down. Okay, so in my head, that reminds me the degree on the top is 1 more than the degree on the bottom. The second one I remember by d over d, meaning the 2 degrees are exactly the same. And the third one I remember is d over d plus 1, okay, which means the top is 1 less than the bottom. If that makes sense to you, absolutely. So d minus 1 over d, if that makes sense in your head, put that in brackets. There are other possibilities. You can have a difference of 2. You could have a difference of 12. You could have any kind of difference. These are the only 3 we're going to see. It's going to be one of these 3 situations. So what do you do with that? Here are the 3 situations. Degree plus 1 over degree. And there's an example of what I mean. So the top has a degree of 2 because it's quadratic, and the bottom has a degree of 1 because it's linear. So that's what a question is going to look like. What that tells you, it's a horizontal asymptote, and it's always at y equal to 0. Anytime you have a degree plus 1 over degree, it's always a horizontal asymptote, and it's always right on the x-axis. Second possibility, the degrees are equal. And there's an example of what one might look like. Degree on the top is 2, degree on the bottom is 2. That tells you it's also a horizontal asymptote, it's just not at 0, it's at some other value. And what value is it at? We take the leading coefficient of p of x divided by the leading coefficient of q of x. What does that mean? You take whatever the coefficient is that's attached to the degree. So leading coefficient means the one that's attached to the highest exponent. You do the same on the bottom and you divide them. So for this example up here, what is the leading coefficient on the top? 2. What is the leading coefficient on the bottom?
1.
If you divide them, 2 divided by 1,
2.
so the asymptote is at x equal to 2. Okay? What do you want to put in the box so that makes sense to you? Okay? Everything I just said? Do you want to do the example? Do you want to write this in different words? What's going to make sense to you? Okay, so let's just make an arrow to him guy. Him guy, what was that? So we just take the leading coefficient. Again, all we care about is the highest power, and what's its coefficient is 2. And then just in brackets, I'm going to write, because that's the one that's attached to x squared, that's where it's coming from. Leading coefficient on the bottom is 1, because it's also attached to the x squared. And you just need to be careful, because we could really write these terms in any order we wanted. I could write this as -5 plus 3x plus 2x squared. So you can't always assume it's the first one. It usually is. And so then our horizontal asymptote is at y is not equal to 2. So I'm just going to repeat. 3 situations. The first one, the minute you see degree over degree, you know that its y is not equal to 0. The minute you see degree over degree, you're going to divide those leading coefficients, so it's still a horizontal asymptote. It's just not at 0, it's somewhere else. For this example, it's at 2. The third one is the one you're not going to like, degree over degree plus 1. There's an example of what one might look like. The degree on the top is 1, degree on the bottom is 2. And this should be oblique asymptote, not horizontal. Oblique asymptote. And in case you've already forgotten, what's an oblique asymptote?
Not horizontal.
Not horizontal, it means slanted. What do? We use synthetic division, which you've never heard of yet, to find the m and the b, and then we're going to put it into y equals mx plus b, and that's going to make a lot more sense when we get down to the example. So just hold on to that idea for a second. How are we doing so far? Okay. So example 2, we're just going to work on finding the horizontal and oblique asymptotes. We're not getting to the graphing yet because I want to do this stuff step by step. So number 2, we're going to identify them and then figure out where they are. First thing you do is look at the degree and look at the degree of the top and the bottom, and then decide if you have situation 1, 2, or 3. So what is the degree of the top? I heard like 5 different answers at the same time. It's 1. What's the degree of the bottom? 2. Which situation? So I make a note degree over degree plus 1. However that makes sense to you. If you like degree minus 1 over degree, if you just want to put situation 3, whatever makes sense to you. Here's how to find an oblique asymptote. I want you to put your pens down, and I just want you to watch, and then I will redo it, because the first time you see this, you're going to be like, what is going on? First thing I'm going to do is I'm going to take the bottom, and I'm going to put it in the correct order. So I'm going to write it as -x squared -x squared plus 9. And what I'm going to do in a second is I'm going to divide that by x. So I want to divide to be able to find out what the asymptote is. I'm going to do an upside down division sign, which is actually interesting because we're the only part of the world that does this the right way. Most people do it backwards like this. So if you look at the way Asia or Europe does long division or any kind of division, they always do it upside down, which really is the correct way. I'm going to write these numbers inside the box because it's what I'm dividing into, but I'm not going to worry about the x's. I'm just going to write the coefficients. So I'm going to write -1, and then I'm going to write a 0, and then I'm going to write 9. So what I have done is I've written the x squared here. We don't have 1, but this would represent the x's, and this would represent the constant. Okay? I don't care about the x's at this point. You'll see why in a second that I don't care. Still with me? Then I'm going to take the bottom and I'm going to say, what is it equal to? Well, it has to be equal to 0. Are you still with me? I just want to make sure I'm not doing this backwards because I always mix this up. Hang on. Okay, no, we're good. I'm going to drop this guy straight down, and I'm going to write my -1 here. Okay, this is called synthetic division. I'm going to multiply 0 times -1, and I'm going to put the answer right there. What's 0 times -1? 0. Then I'm going to add vertically. What's 0 plus 0? Still with me? Then I'm going to repeat it. I'm going to say 0 times 0 is, and I'm going to put it right here. And now I'm going to add vertically, and 9 plus 0 is, still with me. This is crazy, I know, when you have never seen it before. All I care about is this right here. And what that is that's the slope of our oblique asymptote. That's the m value. I also care about this right here. That's the b value. I could care less about what's in the third spot. The answer you get out, the m is always the first number, the b is the second number. What that tells us is the oblique asymptote is y equal to negative x, and I'm going to put the plus zeros so just so you see what we're doing with the b. There's where the oblique asymptote is going to come from. Questions? Okay, I will do it with you now. Yeah, we're kind of either or with the obliques, actually. I wouldn't care if you did or didn't. Yeah, I don't know why. We should put it, but yeah, we just don't. Okay, so now let's do it together. Step number 1 is I'm going to reorder the bottom. And I don't actually need to write it down because it's not part of my division. I just like to see it because I'm visual. And then what I'm going to do actually is just add in that plus 0x just to remind myself that there is no x's in the equation because my columns need to be x squared and it's x and numbers. And I'm going to do my upside down division sign. Highest exponent's going to go first, followed by the least highest exponent, followed by the constant. And if you don't remember c, then write the word constant. So I'm going to have a -1 in the first column, a 0 in the second column, and a 9 in the third column. The number here comes from the numerator equal to 0 and solving for the variable. Numerator, denominator, numerator. Okay. In this case, we just have an x, so x equals 0. Okay, later we're going to have something else on the top, and you'll see when it's equal to something else. Okay, so set up inside is the polynomial in order. Outside is the numerator equal to 0. First number always just drops straight down. Then we're going to multiply by the number on the outside and put the answer up in the second column. 0 times -1. And then we add vertically. Ooh, I didn't want to do that one in red. Then we just repeat, multiply by the number on the outside, put it in the next column. Add vertically. I always just cross out the 9 because it's meaningless in this question. Next unit, I'm going to show you what it's actually used for, but in terms of the rational functions, it's meaningless. This is your m, this is your b. So our oblique asymptote is y equal to -x plus 0 if you need to have it there. We're going to come back and practice that again. I know that's a lot when you've never seen it before. B. The degree on the top. The degree on the bottom. Which of the 3 situations? And we're always relieved when we get that one because it means it's not oblique, which is a lot less work. If it's degree plus 1 over degree, we know automatically it's y cannot be 0. And that's just situation number 1. Letter C. Okay, so same numerator as the last example, but we're going to change up the denominator. Yeah?
How do you know that it's, like from the original, how do you know that it's
Because this is 2 and this is 1. So the top is 1 higher. Degree on the top. Degree on the bottom. Which of the 3 situations? Again, we're like, yay, it's not oblique, but it means I have to do a little bit of work. Leading coefficient on the top. Leading coefficient on the bottom. What do we do with them? We divide them. So y cannot be -1/3. Letter D. Degree on the top. Degree on the bottom. Situation. Y does not equal 0.
Is it always going to be here?
If it's degree plus 1 over degree, always. Letter E. Degree on the top. Degree on the bottom. Situation. Y cannot equal 0. Are you okay with identifying which situation? I'm okay if you're not okay with this right now. I just want to know identifying situation 1, 2, and 3. Okay. Last thing we're going to do is we're going to put all that together. So example number 3, we're going to determine the NPVs and whether they're asymptotes or holes. We're going to determine any horizontal or oblique asymptotes, and we're going to find any intercepts, because those are the 3 things we're going to need to be able to do the graphs that we're going to get to on Thursday. Because I am left brain, I like to do it in 3 columns, where I do the vertical asymptotes, then the horizontal, then the intercepts. If you're right brain, you don't care. So this is going to be vertical asymptotes or holes. This is horizontal asymptotes or oblique asymptotes. This is going to be our intercepts. That's intercepts. This is all we're going to practice today and tomorrow, because we need to get this down pat in order to do the graphs. How do you figure out vertical asymptotes or holes? You factor anything you can, top, bottom, whatever is possible. What could we factor? What does that tell us? So hole or asymptote? Asymptote. X cannot be 4. And I'm going to box that because when we eventually get to the graphs, really that's all we need to know. I really don't care about the top. I don't care about that factoring. All I care right now is there's a vertical asymptote at x equal to 4. Horizontal asymptote. How do we know? So what's the first thing we do? Analyze the degree. What's the degree on the top? What's the degree on the bottom? So that's degree over degree. Okay, now what? Okay, so we go back to here. What am I looking for? Coefficient of the leading variable in the top. Coefficient of the leading variable on the bottom. Divide them. Y cannot be. No, coincidentally. Yes, but not in their world. Yes. X and Y intercepts, nothing new. You've been doing this for linear equations in grade 10. We did it for quadratics in grade 11. We've done it out the yin-yang. What are asymptotes, or what are intercepts? Where it crosses the x-axis and y-axis. So let's start with the x-intercept. How do we find an x-intercept? Set y equal to 0. So we get 0 equals 2x plus 2 over x minus 4. Multiply both sides by x minus 4. And sometimes it helps to bracket to see what we're doing. So we're just multiplying it up, and what happens when the other side is 0? It's just 0. So the bottom actually ends up just disappearing because we've multiplied it by 0. Okay, how do I solve this little linear equation? Now, I like to write this as a coordinate pair so that your brain sees it as a point, not as a vertical asymptote, not as anything else, not as a whole. It's a coordinate point on the graph. Okay, you don't have to write it as a point. I just find for me it helps me remind it's just a point on the graph, nothing more. I was going to try to squish y-intercept here, but I don't like that, so I'm going to go underneath. How do we find a y-intercept? X equal to 0. Okay, so I have y, 2 times 0 plus 2, and on the bottom, 0 minus 4. So 2 over negative 4. Again, I like to do it as a coordinate pair, just to remind myself later, it's a point, not a horizontal asymptote, nothing else, just a little point on the graph. That's all we're practicing today and tomorrow, is just getting these 3 things, and then on Thursday we'll take them, what's tomorrow is Thursday? Friday, we'll take them and actually draw the graphs from these. How are we feeling so far? We're okay? Still want to keep going, or you want to stop, do the rest tomorrow? Let's at least do one more. April saying stop. We had finished the end of this page tomorrow at some point. Do you want to do one more and then stop, or do you want to keep going? Okay, let's keep going. Ooh, I don't like that paper. Yes, it is. Well, no, I'll say it depends on the function. Again, I'm into the columns because I'm left-brained. I can't help it. Oop. Left brains, we like columns, and we like order, and we like lists, and we like steps that always work. Right brains find that restrictive. I once asked my very, very right-brain friend, how do you grocery shop? Because I know she doesn't have a list. And she's like, oh, no, I never write a list, which I don't understand because I can't go to the store without a list. She says, well, I just picture the cupboards, and whatever's not there, that's what I put in the cart. I don't get it. I can't do that. I can't. Okay, talk to me about vertical asymptotes. How do we find them? Factor, 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 factor. I had an offer of x plus 2 and x minus 1. What does that tell us about the bottom? Which is more probable, a vertical asymptote or a hole? Vertical asymptote, because if you look at the graphs we started with, there were far more that have vertical asymptotes than have holes. So I'd say 75% of the time you're going to get a vertical asymptote. Okay, talk to me about horizontal. Okay, degree on the top, degree on the bottom. Okay, what do we call that? Conclusion. We're always happy when we get degree plus 1 over degree. We're like, no thought, no work. Okay, I always do the x-intercept first, but it doesn't really matter. How do we get rid of the x plus 1? Multiply it up so it disappears. Oh my God, what kind of equation are we left with? There are 5 ways to solve a quadratic. What are the 5 ways to solve a quadratic? Well, think about it. What have we already done over here? So then there's no point doing another method over here because we've already done that work here. You could quad formulas if you wanted to, but why would you do that? I have the offer of x cannot equal negative 2 and cannot equal 1. So those equation signs there, that's a half mark off on the exam. You need to be careful. Are we doing anything with asymptotes here? So is that true that x cannot equal -1? So just be careful how you're writing this. Okay, that is where it crosses, so it is where it equal. Again, I like to go further and give the point.
So it's, so would it just be?
It would just be equal. Solving quadratics are just equal. Chantal, you okay? You have a really weird look on your face.
Yeah. Why is it not equal?
Because that's what somebody said. So then I just paused and said, okay, if you put this, not good. So it should be equal sign. Should be equal sign. And again, I like to put them as a point because when we go to graph, I want to be really clear. It's a point, nothing else on the graph. It's just a point that the graph crosses through. Now, when you're doing the y, save yourself some time. You know this is going to be 0 and this is going to be 0. So what's going to be left on the top? And what's going to be left on the bottom? And what happens when we divide something by 1? Stays the same. Show me your thumb so far. How are you in rational graphs? I'm getting this. I'm kind of getting this. Okay, I suggest we pause there because the next one is oblique, and I want it to be fresh in your head tomorrow. So we can pause, finish off 3 and 4. Do you want to do number 6 today? Because it's exactly what we did first period. No, we'll do it tomorrow. Okay. So if you're not quite done the homework from yesterday, you can finish that off. If you're done, yay, relax. Play some Candy Crush. I'm stuck on 208. It has been like 6